Okay, this is 1-4 part B for Algebra 2, quadratic and square root inverses. Okay, what are the two types today that we're going to be looking at? It's quadratic and square root functions, which are opposites. The inverse of a square root is or quadratic. An x squared is a square root. Inverse of a square root is a x squared. So they are inverses, which means they basically they will cause a mirror image across that y equals x. Let's look at an example. So if we switch f of x to y, change the x and y's positions, and then solve for y using PEMDAS, we replace the y with the negative x. So we have f of x is x squared plus 3. That's our quadratic. We change it to y equals x squared plus 3. We switch x and y's positions, solve for y by subtracting x, and then we have a y squared here. So what's the opposite of squaring something? It's taking the square root. So we take the square root of it, and we get the square root of x minus 3. So something I want you to notice, the original had a plus 3, and the inverse has a minus 3. So that's one of those clues that you can use to help identify the inverse. You will have the opposite operations. That's one of the things. And then opposite of square is a square root. If it's out, so that's just a way to help kind of narrow down your answers. Okay, so square root of x minus 3 is the same as g of x, which is the square root of x minus 3. So f of x is the original, g of x is its inverse. Seeing inverses graphically, so we have graph y equals x first. That way you have something to compare across. Then you graph your original function, which is f of x equals x squared. Then we graph the inverse. The inverse should reflect across the x-axis, or across that y equals x. So this little bitty piece right here that fell underneath the y equals x flipped up. This piece right here flips down. Notice you did not get the bottom. That's because if we put the bottom on there, which would have been the other side of this quadratic, the square root would no longer be a function. So we can dot it in to help us remember that this whole thing actually did get turned on its side, or we simply give it domain, we limit it by the domain. So major takeaways, quadratics and square roots are inverses. The opposite of squared is square root. On a graph, the inverse is reflected across the y equals x. So when we do this, we want to use, we're going back to a little bit. We're saying, okay, well, we have a function, we have a function, f of x is inverted. So where is f of, what is the f of negative 11? So really, this is still going back to our functions. Remember before we had this example where they were listed out as pairs. At negative 16, f of x is negative 11. So at negative 11, what is our f of 16? F of negative 11? What x value would we have gotten? When y was negative 11, what's our x? That's what we're really looking at. Our y was negative 11. What's our x? It's negative 16. And I have a typo. Sorry, my bad. So f of negative 5 here, we have f of negative 5. We're going to be looking at where y is 5, what is our x? And when y is 5, our f of negative 1 of 5 gives us our x being 3. Okay, so we wanted to restrict the domain of each of the quadratics. So we have 3x squared. When we do that, we restrict our domain by saying we're only going to be looking at the positive side of that quadratic, not where x is negative. And then we can do our inverse. If we don't just restrict it to the positive x's, when we do the inverse, it becomes a non-function. So seeing this again on a graph, you can see how we had the original quadratic. We restricted the domain by telling Desmos, put it in here. Here's your domain. I want you only to draw that side. Here's my table for that function using that domain, and you notice the -1, -2, and that did not graph. It's showing on our table, but that's because we did this part you do not restrict. It's just showing the domain. And then when we have our flipping, we flip all of our numbers and we end up with our x, our square root. Okay, so that is the end of this note. Make sure you copy down at least a couple of these these images of what it would look like, what the inverses look like. This one's a really good one for your notes, because that way when you're looking at it going, okay, I know I need to do the square root. What is the inverse of a square root? It's a quadratic. What would that look like on a graph?